Okay, class. So last week we had a wire and a battery and light bulbs, and we saw that the battery went from the wire into the light bulbs, and what happened to the light bulb?
It turned on.
Correct. So today we are going to model a light bulb, that same exact thing that we saw, and we are going to be the wire. This table is going to be our battery, and these pennies in our hand are going to represent electrons. So Corey is standing at the negative end of the battery, and Ruriko is standing at the positive end. If we want to get our pennies to go through, and we want Ruriko to drop her electrons at the positive end, what must we do first?
Rico needs to drop her penny.
Correct. Ruriko needs to drop her penny, and then Rachel can pass it, and so on. Good. And we keep passing them, and the electrons are moving all the way through the wire. With one hand behind your back, sorry.
This is the last penny.
And Corey has the last penny. So what happens when we run out of pennies on the negative side?
Battery died.
The battery dies. That's right, Ruriko. So now let's try something else. If we all take one step back, what happens if I can't reach Rachel?
Then the electrons stop at you.
Yeah,
They
there's
can't move.
exactly. There's a break in the wire. So now let's say we'll move some of our pennies back to the negative end, and Ricia is going to act as an insulator, and we're going to continue passing our pennies, but Ricia is going to refuse to take a penny from someone or give a penny. So let's try. So what has to happen first?
Rico has to put her penny.
Ricia's not taking, so Ricia is representing an insulator. So what happens to our electrons?
They stop.
They stop moving. That's right, Rachel. So now, Rachel is going to act as a light bulb. So when I pass my electron penny to you, you have to spin in a circle. So. So what's happening to our light bulb?
It's turning on.
Right. And are the electrons moving faster or slower through the wire?
Faster.
But what's happening when Rachel gets it? Is she
slower.
I'm slowing down the
Right. So now we're going to all act as light bulbs, and each person must spin. And I wonder, let's think about something. Will our light bulbs be super bright or super dim if we're all acting as light bulbs on the same wire?
Dim.
Dim. Let's test it out, students. Lots of spinning. Lots of spinning. Oh no! All right. What's about to happen to our battery?
Die.
Why is it going to die?
No
Because
electrons.
I don't want
anymore. Pennies.
All the pennies are on what side of the battery?
The positive.
Good. All right. So all of our light bulbs were as dim as when Rachel only was the light bulb. Our light bulb was brighter. Right. So what we just did here was a model, and what did we model?
A battery and a wire and a light bulb.
So now, when you see a wire or something plugged into a battery or an outlet, you now know that the way the light bulb gets right is from what?
Electrons.
And what do they do?
Travel. They move things.
All right. Good job.
Thanks, teacher. Thanks, Anna.
That was like 5 minutes.